Did you know? Some of the biggest breakthroughs in human history came from experiments that were weird, wild, sometimes completely accidental. I'm Chris, and today we're diving into the moments that made scientists go, "Wait, what?" From a guy dropping stuff off a tower to another guy just playing with pea plants in his garden, these aren't your typical high school chemistry lab projects. These are the big ones, the game changers, the paradigm shifters. We're talking about discoveries that completely rewrote the textbooks and forced us to rethink everything we thought we knew about the universe. So get ready. These experiments turned science upside down. All right, first up, let's talk about Ernest Rutherford. Back in the early 1900s, the model of the atom was this thing called the plum pudding model. Imagine a blob of positively charged goo with little negative electrons stuck in it, like plums in a pudding. He set up this experiment where he fired tiny positively charged alpha particles at a super thin sheet of gold foil. But then, something absolutely bonkers happened. About 1 in every 8,000 particles didn't go through. Instead, it bounced back, as if it had hit a solid wall, with a tiny, incredibly dense, positively charged center, the nucleus. Next, we have an experiment that was a massive success because it was a massive failure. They called that medium the luminiferous ether. Two brilliant scientists, Michelson and Morley, set out to prove it. They built an interferometer, and they found absolutely nothing. Until a young patent clerk, Albert Einstein, arrived. And just like that, relativity was born. Let's head to a monastery garden in the 1860s, where a monk named Gregor Mendel was doing something that seemed, well, kind of boring. He was meticulously crossbreeding pea plants, thousands of them, flower color seed-shaped plant height from one generation to the next. For example, when he crossed a purple-flowered plant with a white-flowered one, he got all purple flowers. The white trait hadn't disappeared, it was just hidden. Through his ridiculously patient work, Mendel figured out that traits are passed down through discrete units, what we now call genes. Picture this, it's the year 1800, and astronomer William Herschel is curious about the sun. So, he sets up a simple but brilliant experiment. He uses a prism to split sunlight into its spectrum: red, orange, yellow, green, blue, violet. He decided to place a control thermometer just beyond the red end of the spectrum. But instead, the temperature on that thermometer shot up even higher than the one in the red light. But we now know it as infrared radiation. For centuries, people believed in something called spontaneous generation. It was the idea that life could just appear out of nowhere. Maggots from rotting meat, mice from piles of grain. That is, until Louis Pasteur came along in the 1850s and decided to settle the debate for good. So Pasteur designed an ingenious piece of glassware, the swan neck flask. He then boiled the broth to sterilize it, killing any existing microbes. However, the curve in the neck acted as a trap. As long as the flask was upright, the broth remained perfectly clear and sterile, for months, even years. But as soon as he tipped the flask to let the dusty broth from the neck wash in, it quickly became cloudy with microbial growth. This next one is probably the most dramatic experiment on our list, and it stars the legend himself, Galileo Galilei. That heavier objects fall faster than lighter ones. A bowling ball should definitely hit the ground before a feather. But Galileo wasn't convinced, so according to the story, he staged a public demonstration. He allegedly dropped them both at the exact same time and landed at the very same instant, or close enough. He proved that ignoring air resistance, the acceleration due to gravity is the same for all objects, regardless of their mass. So, what is heat, really? Back in the 1840s, scientists believed it was this invisible fluid called caloric that just flowed from hot things to cold things. But, you know, a brewer and amateur scientist named James Prescott Joule had a totally different idea. To prove his point, he built this incredible apparatus. Picture a large insulated container of water with a paddle wheel inside. Here's the setup. When the weight was released, it would fall, causing the paddle wheel to churn the water. Joule, being super meticulous, measured the starting temperature of the water. Then, he let the weight fall a set number of times, doing a precise amount of mechanical work. After all that churning, he checked the water temperature again, and sure enough, it had increased by a tiny but definitely measurable amount. Joule basically established a direct relationship between mechanical energy and thermal energy, a concept we now call the first law of thermodynamics. Is light a particle, or is it a wave? But in 1801, a polymath named Thomas Young came up with an experiment so simple, yet so profound, it completely changed the game. It's called the double-slit experiment. Here's how it goes. You take a barrier with two tiny parallel slits in it. If you shot solid particles like tiny paintballs through the slits, you'd expect to see two distinct lines of paint on the screen behind it. Instead of two simple lines, he saw this complex pattern of many bright and dark bands, an interference pattern. That's classic wave behavior. Imagine dropping two pebbles in a pond. The ripples interfere with each other. The bright bands of light were the peaks, the dark bands were the troughs. And here's the really weird part. Even single particles of light, photons, create this pattern over time, as if each particle goes through both slits at once. This story isn't about a single eureka moment, but about the sheer brute force power of trial and error. By the late 1870s, loads of inventors were racing to create a practical, long-lasting electric light bulb. It was finding a material for the filament, the part that heats up and produces light, that wouldn't burn out almost instantly. This is where Thomas Edison and his team at Menlo Park come in. So they started testing, and testing, and testing some more. Edison famously said, "I have not failed. I've just found 10,000 ways that won't work." Legend has it they tested over 6,000 different plant-based materials alone. Finally, in October 1879, they tried a piece of carbonized cotton sewing thread, and it worked. The bulb glowed with a soft, steady light for 13.5 hours. His relentless, systematic experimentation is what turned it from a laboratory curiosity into a technology that would, well, light up the entire world. Back in the 1920s, most people thought the whole universe was just our Milky Way galaxy, sitting quietly in a still, unchanging cosmos. But then, astronomer Edwin Hubble, using the Hooker telescope at Mount Wilson Observatory, was about to completely change that idea. He started by studying these faint, fuzzy patches of light in the sky, which people called nebulae. Hubble proved many of these nebulae, like Andromeda, were actually entire galaxies themselves, and noticed the light was shifted toward the red end of the spectrum. Nearly all galaxies are moving away, and the farther away, the faster they recede. The entire universe is expanding. The race to discover the structure of DNA in the early 1950s was one of the most intense competitions in scientific history. That piece was provided by a brilliant but often overlooked scientist named Rosalind Franklin. She was an expert in a technique called X-ray crystallography. In 1952, she and her student captured a stunningly clear image, photograph 51. The image was a distinct X shape. To a trained eye, that X was unambiguous evidence of a helical structure. It gave them the final clue to build their now famous double helix model. It was Franklin's meticulous experimental work and her groundbreaking image that truly unlocked the secret of life. A French physicist named Hippolyte Fizeau came up with a wonderfully mechanical and clever way to measure it on Earth. His result was astonishingly close to the modern value, providing the first reliable, non-astronomical measurement of the speed of light. Our final experiment takes us to the largest machine ever built by humanity, the Large Hadron Collider at CERN. The theory predicted the existence of a particle and its associated energy field, the Higgs, and smashing them together inside massive detectors. Finally, on July 4, 2012, scientists at CERN announced they had observed a new particle consistent with the Higgs boson. And there you have it. 13 experiments that completely rocked the scientific world. From the simplest setups with pea plants and thermometers to the mind-boggling complexity of the Large Hadron Collider, the common thread here is human curiosity. It's that drive to ask why and what if. These stories show us that science isn't a neat, clean list of facts in a textbook. It's a messy, exciting, and often surprising process of discovery, filled with failures, happy accidents, and moments of pure genius that change how we see everything. What I love most about these stories is that they prove anyone can contribute to our understanding of the universe. It wasn't just certified geniuses in ivory towers, it was a monk, a brewer, and countless stubborn experimenters who just refuse to accept "that's just the way it is" as an answer. They remind us that the next world-changing discovery might not come from where we expect. It might be brewing in a garage workshop, a university basement, or in the mind of someone watching a video just like this one right now. The universe is still full of mysteries, and the next generation of groundbreaking experiments is already underway. What will we find? Dark matter? The secrets of consciousness? Life on other planets? Who knows? But it's going to be an incredible ride finding out. If you enjoyed this journey through scientific history and want to keep exploring the amazing world around us, make sure to hit that like button and subscribe to the channel for more daily Weird Wise Facts. Thanks for watching, and I'll see you in the next one.